So you've probably heard a ton about 5G, right? Faster downloads, faster streaming. Well, that's just the tip of the iceberg. Today, we're going to dive deep and show you why 5G is not just another upgrade, but a totally revolutionary platform that's designed to connect, well, literally everything. But first, let's give credit where credit is due. 4G LTE was a total game changer. It's the reason we can stream videos on the go, the reason we have app stores. It basically created the always-on digital world we live in. It was all about connecting us.
But here's the catch. 4G was built with this kind of one-size-fits-all approach. I mean, it was perfect for getting our phones online, but now? That design is really starting to creak under the pressure of all these new demands.
So, what happens when it's not just our phones anymore? What happens when it's our cars, our factories, our cities, our hospitals, and they all need to be connected, each with totally different requirements? Yeah, that's the big question, and that's exactly the problem 5G was built to solve.
Okay, so this brings us right to the heart of what 5G is all about. It's not just one single network. It's way more like a flexible platform built around three, let's call them superpowers. Each one is designed to handle a fundamentally different kind of communication, and it can do it all at the same time. All right, first up, we have Enhanced Mobile Broadband, or eMBB for short. This is pretty much the faster phone part that you've probably already heard about. It just supercharges our mobile internet, making things like really smooth augmented reality, high-def VR, and downloading massive files in just seconds actually possible. Okay, number two. And honestly, this is where 5G's potential just gets mind-blowing. It's called Ultra-Reliable Low-Latency Communication, or URLLC. We are talking about connections that aren't just blazing fast, but are also incredibly reliable, like rock solid, with delays as low as a single millisecond. This is the kind of connection you need for things where a split-second delay could be disastrous. Think remote surgery, fully automated factories, or cars talking to each other on the highway.
And that brings us to the third superpower, Massive Machine-Type Communication, or mMTC. Now, this one is all about pure scale. It's the ability to connect a huge number of low-power devices. We're talking sensors, meters, you name it, all packed into a really dense area. This is basically the backbone of the Internet of Things, the thing that will power everything from smart farms to entire smart cities.
Okay, so take a look at this chart. This really puts the jump from 4G to 5G into perspective. That smaller shape in the middle, that's 4G. The huge one on the outside, that's 5G. And as you can see, in literally every single category, peak speed, how many devices it can handle, efficiency, latency, 5G is just a massive, massive expansion of what's even possible.
Let's put some actual numbers to that, because they are pretty wild. Peak speed, 4G maxes out around 100 megabits per second. 5G, it can theoretically hit 20 gigabits per second. That's a huge difference. Latency, that delay, 5G can drop it from around 100 milliseconds all the way down to just one. And how many devices can connect? We're going from about 100,000 devices per square kilometer with 4G to a full 1 million with 5G. I mean, the scale of improvement is just staggering.
So, the big question is, how on earth does 5G pull all of this off? Well, it all starts with some seriously clever upgrades to the radio technology itself. The way signals are actually sent and received through the air. One of the key pieces of the puzzle is something called massive MIMO. So picture this, a 4G tower might have a handful of antennas. A 5G base station, it can have 100 or even more. The best way to think about it is like upgrading a little two-lane road into a massive multi-lane superhighway. It lets the tower handle tons of separate data streams all at once, which just multiplies the network's capacity like crazy.
And working right alongside that is another cool trick called intelligent beamforming. You see, a 4G tower kind of shouts its signal out in all directions, like a big megaphone. But a 5G tower, it can form a super focused beam of data and aim it directly at your device. This is way more efficient, it cuts down on interference for everybody else, and it means you get a much stronger, more reliable connection.
And then, of course, there's the radio spectrum. 5G gets to play with a much wider range of frequencies. You've got the low-band stuff, which gives you that wide foundational coverage, kind of like 4G. Then you have the high band, what people call millimeter wave. That's where you get those insane multi-gigabit speeds, but the catch is, it doesn't travel very far. And right in the middle, you've got mid-band, which a lot of people call the sweet spot. It offers this fantastic balance of really impressive speeds and pretty good coverage.
Okay, so smarter radios are awesome, but the real revolution with 5G? It's completely invisible. It's hidden away in the brain of the network, the brand new 5G core. And this is the part that takes 5G from just being faster to being something fundamentally different.
So the old 4G network core was, well, monolithic. Think of it like a restaurant with a fixed, set menu. You get what they offer, and that's it. But the new 5G core uses what's called a service-based architecture. A much better analogy is a modern food hall. You've got all these different independent stalls, or in this case, microservices, that can be mixed and matched on the fly to create literally any kind of service you can imagine. It makes the whole network incredibly agile and flexible.
And this new architecture is what makes the absolute killer feature of the 5G core possible: network slicing. Okay, stick with me here. Imagine a big public highway. Network slicing lets the network operator create dedicated private lanes on that highway. So one lane could be optimized for extreme speed for your phone. Another lane could be built for the super low latency that a factory's robots need. And a third lane could be designed just to handle millions of tiny sensors in a smart city. And the best part, they're all running securely and totally independently on the very same physical road.
This diagram gives us a really good look at how this works in the real world. So one person might be using two different slices at the exact same time on their phone. Maybe one slice is for a super high-quality video call, while another is just for a tiny, low-powered data connection to their smartwatch. At the same time, someone else nearby is on a completely different slice just for their regular internet browsing. Each slice is basically its own private, custom-built virtual network, perfectly designed for one specific job.
Okay, so we've got the theory down, right? The three superpowers, the smart radios, and that revolutionary core. Now let's talk about what really matters. How does all of this come together in the real world, in applications that are already starting to change entire industries?
And the impact is, well, it's incredibly broad. In the car industry, it's the super low latency network that's essential for connected and autonomous vehicles. In healthcare, it's what makes remote diagnostics and even remote surgery possible. Manufacturing, we're talking fully automated smart factories. Retail is getting these amazing immersive in-store AR experiences. The list just goes on, from agriculture to education. And one of the first really big applications that's hitting consumers right now is something called fixed wireless access, or FWA. This basically uses the huge bandwidth of 5G to deliver internet speeds that are like fiber optics, but to your home or business, completely wirelessly. For a lot of people, this is a powerful new choice for high-speed internet, especially in places where getting a good wired connection has been tough.
And just to really hammer home the scale of this whole Internet of Things idea, I want you to remember one number: 1 million. That is the number of connected devices that 5G is built to handle in a single square kilometer. It's that kind of massive density that really unlocks the potential for a truly connected world.
So if there's one thing to take away from all this, it's that 5G is so much more than just a speed boost for your phone. It's a flexible, programmable, and incredibly powerful platform. Really, it's the foundation that the next decade of innovation is going to be built on.
And that kind of leaves us with one final big question to think about. The last generation, 4G, it put a supercomputer in every single one of our pockets. And look how much that changed the world, in ways nobody could have predicted. So what are we going to build this time? What amazing things are going to happen when this generation gives us the power to connect not just every person,